Part A is an area problem, so we're simply going to go top curve minus the bottom curve. So there I did right there. And then top minus bottom is a dx problem, so go left to right, use the x's that take you across that bounded area. Notice that this one is a no calculator problem, so make sure you're practicing all this without the calculator. Just remember when you integrate x to the 1/2, that's going to be x to the 3/2 divided by 3/2, which means you'll multiply by the reciprocal, multiply by 2/3 right there, so you're going to get a 4/3. When you plug in 9 to the 3/2 without the calculator, do the bottom part first. That's the square root of 9, which is 3, and then 3 cubed is 27. Then you can go 27 divided by 3, which is 9, times it by 4 to get 36 right there. So just practice that without the calculator. Part B is a volume problem. And so I'm going to do the disk method here, where like our rectangle is perpendicular to that axis of revolution. And when I do the disk method, we're going to go capital R as a distance from that axis of revolution back to your farther edge of your bounded area. That's one of your 4 biggest scenarios. Remember, when you measure from that axis down, it's always that number minus y. And since it's a dx problem, use the x's. And then your little r is the distance from your axis of revolution to your closer edge. So the distance between the 7 and the 6, that's just 1 unit every single time. So there's your little r. And then it just says write it, but do not evaluate it. So you ain't got to waste your time trying to multiply all that stuff out and actually integrate that thing. Just write it, set it up. Capital R squared minus the little r squared, dx problem, got the pi guy out in front, and you got the numbers attached to your integral. Cross section. Remember, when you do cross sections, you integrate the area of your cross section shape. So they tell us y-axis. So when I see x-axis, that's automatically a dx problem. When we see y-axis, that's automatically a dy problem. What you need to do is we need to draw a line segment perpendicular to that given axis there. So there's the S, that's perpendicular to the y-axis. Now remember, when it's up and down, that's top y minus bottom y. But when it's on its side like that, that's right x value minus the left x value. So find the length of that S, that's right x minus the left x. And then the right x is this curve. And so that equation is y equals 2 radical x. You got to make that get x equals something in terms of y there, okay? So that's why I just made it that y over 2 quantity squared, and then your left x is that x equals 0 right there. So I did right curve minus the left curve, got the y squared over 4, and that is the length of the base. The S is always the base. And then so like if they say we have squares, you integrate that thing squared. If they say we got equilateral triangles, you integrate radical 3 over 4 times that thing squared, right? But here they say we have rectangles, so I need to integrate the area of a rectangle, which is base times height. This is the base, so that goes in there. And then the height, whenever they give us rectangles, they have to tell us something about the height. Here they tell us the height is 3 times the length of the base. So there's the base, there's 3 times the length of the base again. And then since this is a dy problem, you gotta go bottom to top. The y's that take you across your bounded area go from the 0 to the 6 right there. Now you're allowed to just leave it like that. You can set that up. If you wanna make that 3y to the 4th over 16, that would be fine as well. But easy problem, we'll make sure we're 100% on stuff like that. Raindrops.